Okay, so here's a rather odd thing that this TV does. So yeah, it comes up with a quarter of a picture, and regardless of what input I use or what settings I set on the side of the TV, never changes. It's always the same. So it also has some shutdown problems with humidity. Humidity seems to affect it quite a bit. So we're gonna tear this thing open, take a look at the power supply, and various other things that might affect the scaling of the picture. So that's tonight's project. Stay tuned. And the model number we're working on is a LG Plasma TV 50PQ30. Okay, so here's the LG Plasma with the back removed. We have a sticker up here with the panel voltages on it. Here is the main power supply, sustain board, and over to the left is the larger sustain board. Oh yeah, here's a T-Con board. All right. So yeah, T-Con's getting the main signal from the video processor board. So here's our main input for video, all your different types of video inputs. Part of that runs over to where? Okay, so to the power supply, of course. And another cord, T-Con, to this smaller sustain board. And we have a ribbon cable from the T-Con going to the large sustain board. And this over here is what I'm afraid of, if any of these have something to do with the fact that the other lower half of the picture isn't lighting up. But as you can see, there's an equal division right here, splitting the two halves. Now that may or may not have anything to do with anything. What I've had to do in the past a lot is when the TV would flake out, the whole picture would flake out, the power would cycle off and on quite a bit. And I would have to come along and wrap the top quite a few times and get something to come back to life. I'm assuming it's going to be A, power supply, B, that sustain board, or C, more likely, this sustain board. And do the caps look bad? Not these. And no, not these. Like I said, it works if I slap it around a few times, so it's probably a bad solder joint somewhere in here. And seeing this, look at the size of the aluminum heat sinks on here, and we've got plenty of regulators and things tied to that. This can be a problem. Sometimes the dissimilar metals attached to the transistors and to the heatsink can cause problems, specifically cold solder joints. There's a couple little trim pots for voltage regulation there. Hopefully we won't have to go into that at all. Here's some smaller capacitors. Again, I don't suspect there's a problem with any of these. As far as addressing the half picture issue, when this thing is lit up, the whole screen does light up, the entire thing. It's just the picture is regulated to the 1/2, or it looks like a quarter screen when you look at it, but it is actually half, and it's kind of condensed out, so it's squeezed out a bit, so people look a bit fatter than they really are. And so I'm gonna take this out, bring it on the bench, and maybe take this out as well. And we'll take a look at these and see how they are faring as far as cold solder joints go. See you in a few. Okay, so here we are down on the bench, and this board is the Y-Sustain, Y-Sus. And there are the part numbers. So we're not going to find anything on top. I mean, we're finding components, obviously, but the problem is probably down here someplace. So flip this over. So I did give it a quick cursory look myself before this taping, but here's what I want to point to. See if we can get in better on this. Look at that solder joint. See how it's all kind of cracked around it? That will probably cause some sort of intermittency. Now it's partnered with this one here. This is actually a different heat sink. So let's take a look around. Let's zoom out. Look around here. See, it's two different heat sinks. And of course there's a whole bunch of goop in between them. Okay, so found a flashlight. And we can finally see some part numbers here. It's like RF 2001. Quite a few of those. What is this? Let's take a closer look at some of the eyelets. Those certainly could also be problems. Oops. Look at that one. RPX 2001. Probably wouldn't hurt to hit a bunch of these with the soldering iron, that's for sure. Okay, so looking around the rest of this board, there isn't too much else that looks bad. So the thing we do want to look at are the bottoms of the transistors attached to the heat sinks. So that's so these guys here. Get our flashlight on it. Zoom in a bit. So as we scan across, they don't really look too bad, to be honest with you. And I'll hit them up anyway, just to make sure. That That might even be empty right there. I'm not sure if there's any a transistor there, but we'll check it out. And this is that sticky heatsink compound stuff, which tend to find everywhere these days. And you can see the impressions of the transistors are pretty well formed into them. On this one, you can see some of the pins are actually sticking through, which first I thought might be a problem, but then if you take a look at the height of this square thermal pad, this other one over here too, much higher than the very bottom of the board. So the board is screwed up against posts that come off of the panel. So these are in no danger at all of actually touching any metal. So I guess that's a good thing. And then just generally scanning around the rest of the board. Here are the edge connectors, or no, rather, here are the edge connectors that go out from the sustain board. So if we zoom in on those a little bit, they look good. They look real good, actually. I don't see any reason to even hit them with the soldering iron. Yeah, there's a couple that are not connected that has no effect on things. And then I have to take a closer look at all the other little MOSFETs and things attached to the back of this board. I'll make some continuity checks. There's diode mode on some of these. I'll just see if there's anything obviously burnt or otherwise ugly. And we'll come back to this again. So this is the ugliest thing I've found. Hit the light on it just the right way, you can see. Actually, a little too much light is not good. You can sort of see that little cracked ring around there. It's always a good idea whenever you see that sort of thing to hit it up with solder. Okay, so then we're gonna go through and hit up a bunch of these joints and see how things work after that. Okay, so we have reinstalled the Y sustain the Y sustain. That's the X sustain. Anyway, reinstalled it, reinstalled the power supply, and same crap was happening. It would turn on for a while, it would run okay, and then it would freak out, turn off by itself, and of course the picture was still 1/2. So got into the service manual of the whole thing, found online, and they give instructions on how to check this, the TCOM board. And I'll see if I can zoom in on this whole thing. So basically they had me check the TCOM board in a very interesting way. So over here on the TCOM board, I'll point with my finger and my flashlight. There's a jumper over to the right here. Anyway, to the right of the big chip in the middle there's 2 points that if you jump them together will generate an automatic series of test patterns. So and the whole reason for this is to check all of the boards in the TV with the exception of the input board, because they said sometimes the input board could cause things to shut off. So that's something you don't want. You don't want the main input board turning the thing off on you. And it would make sense too with the problem I was having, where it was outputting a half of a picture. Yet the rest of the TV seemed okay. Like the black areas were lighting up and all that. So it was a very strange problem. So anyway, you disconnect the main cables, as you can see over to the top right and the top left, I should say, and over on the right next to that. Disconnected those, and the other one is the LVDS cable, which runs over to the TCOM board over here on the top. On the very tippy top of the TCOM board goes the LVDS cable. See that black connector in the middle, top? That's where it goes. So, what they said what to do was connect it up, have that jumpered out, which is the AutoGen jumper, over to the far lower right of the big IC, and you turn it on. And all these connectors are disconnected, and the TV may or may not run, but it'll help you figure out where the problem is. If it's that, then the TV should run. Okay, so this is what it looks like. This is the AutoGen pattern happening from the TCOM board. Obviously, it's programmed in there somewhere. And it just does this series of squares and grid patterns and grayscales and all sorts of interesting stuff. And in a couple of these, you can sort of see the outline of where my picture was kind of burned in right after the blue pattern here. You can sort of see that. I don't know if you caught it quick enough, but it's sort of a burn in of the area where the TV was showing the picture for so long. All right, so that is it, basically. I let this thing run for almost an hour earlier, and it didn't shut off, didn't do anything weird. So that's the problem, is that input board. Surprise, surprise. So yeah, on the input board, I'm gonna see if I can just find a new input board, because yeah, I could try and fix it. You know, the big LSI chip that's in there, which does all the scaling for all the inputs and whatnot, would probably, I'm sure, fix that problem. But it may still have problems with shutting off the TV and all that. So probably just worth it to see if I can find me a new used input board. So we'll see how that works out. So stay tuned. Okay, so thanks to the fact that I was able to enable a jumper here on the TCOM board, it's all the way over there. There we go. But yeah, it's just two little jumpers on there that puts it into a not self-diagnostic, but internal pattern generator. So you have to disconnect the input here and then put it into that mode, and it displays all those cool little test patterns that you saw before. And that helped me figure out that this board was okay, this board was okay, this board was okay, and that board was okay, and all the others are along the bottom as well. So that only left this guy, the main input board. So as you can see, and you have to be careful, make sure you get the right number, the exact number that's on that sticker. And I'll show you what the picture looks like as soon as I get this back cover on. Okay, so the back is back on, the boards have been replaced, and let's see how it looks. And bingo, there we go. Full screen, full color, and it looks just wonderful. So, Operation Plasma has been fixed. So again, just to go over real quick, the had a picture of about a quarter of a screen in the upper left-hand corner, and it turned out to be the scaling of the input board was messed up. We checked all the other boards by means of enabling a jumper on the TCOM board, which generated a bunch of test patterns. So the fact that you get all the test patterns means that everything else is working, which leaves, of course, only the input board. So bought one, made sure it was the right one, replaced it, and bada bing, bada boom. So, pretty easy fix because I bought a board and didn't repair it. I did try some capacitors on it just for the heck of it, but that didn't work out. So, and wasn't about to find the actual IC chip, and it was a BGA as well, so it had 100 some odd pins, little balls that would need to have been soldered. Not going to go through all that for something that I could purchase for about $70. So went the cheap and easy option. I know this channel's more about repairing, but hey, sometimes economy works into it too. So if it's cheaper to fix something by means of just replacing a board and saving a lot of time, then that's usually a better way to go. If there's no other option and it's something that you really need to want fixed, then that's when you got to go digging deeper. But fortunately, you didn't have to. Besides, it's a TV. If it really gave me a hard time, I could have just replaced it. But anyway, that's it. It works. Give me any thoughts below in the comment section. Don't forget to subscribe and ring that bell. All right? I hope to generate more content as time goes on in the future. So again, thank you for tuning in, and see you next time.